Okay. Hello everyone. So this is another requested session. And on this one, we're going to focus on IP addressing using vlsm, obviously. I think everyone understands how to subnet. Difficulties come probably when you are using now variable length subnet masks. So we're going to do a packet tracer. This one is 11.9.3. And I think it's going to be divided in three parts. The first part, this is the first part one, examining the network requirements. So for this one, we're going to look at network address. In real life, this is the network address you're given by your ISP, that's your service provider. Okay, and after all, I need internet. I have this amount of hosts or devices on my network. They give you an address to meet those requirements. So here we have 192.168.720. No IP address here, the network address, I mean, that's the network address from the ISP. Then for the requirements, we have 58.29.15.7 hosts for 4 LANs, switch 1 up to 4. I think another requirement that you might need to take note of is the requirement for this one link here. This one in red, the serial link. It's a network on its own. So giving us a total of 5 networks that we're going to have with the different number of hosts from 58, 29, 15, 7, then 2 hosts for the one link. So basically, those are our network requirements, and that's it for part one. I'm going to be skipping some of these steps and questions because I think the objective is for us to understand how do we subnet, how do we come up with the IP addresses, and how do we configure those IP addresses? Where do we configure them to include the default gateways as well? Then test for connectivity. All right, so step 2, we have designed the vlsm addressing scheme. So this is where all the subnetting will be done. I think this is where the IP addressing as well will be done. We have a table. I have a table I'm going to be showing you later on, where we'll be doing our IP addressing scheme. So part 2 is for later. Then we have part 3, assign IP addresses to devices. This is the configuring part. We're going to be configuring this network with IP addresses. Then we verify connectivity. And after that, I think that will be it. So I think to begin, understanding at this point, I think everyone understands what an IP address is, what a subnet mask is. We have a network address, we have a host address. Those are sort of pre-requirements for doing this. So if everyone understands that, I think we can move to part one, where we have our networking requirements. So I'll be sharing my whiteboard. I think it's much easier to be using the whiteboard in this case. So I'll be sharing my whiteboard so that, okay, voila. Okay, so I'll be using the whiteboard to analyze the network requirements and go into the subnetting. Let me move this here. Right. So for part one, so we have 3 parts. Okay. I'm a bit rusty with these devices. Okay. Part one, don't mind the handwriting as usual. So here we're going to examine the requirements. Examine the requirements. So the first thing, we have the network address from the ISP. Network address 192.168.720/24. Then for our requirements, we have 4 lines: line 1, line 2, line 4, line 5. Then we have the one link, the last one. So these ones are named SW, switch line 1, 2, 3, 4. Right. For this one, it has how many hosts? 7 hosts. Then the next one, 15. Then we have 29. Then we have 58 hosts. Then for this one link has 2 hosts. As you said, every time you have a one link, you have a router and you have a router here. The connection between the two is a network on its own. Yeah. So when you are doing your IP addressing, don't forget it's a network on its own. It's supposed to have a subnet on its own, and it has 2 hosts because you're going to assign an address on this interface here, then another address on that interface. 2 addresses. So 2 hosts for our one link in this case. So suppose you have maybe another router here. Let me put another router here. So this is the one link, another router here. We have another link there. We have another link there. This means we now have 1, 2, 3 networks of the links only. So if you have other networks here, this will be 4, 5, another line here, another line here, 6, 7, and it goes like that. Do not forget a one link is a network on its own. Right. So done with the network requirements. These are the network requirements. So you were as an engineer, do a network engineer, you are given an IP address 192.168.720/24. You are given an IP address. Now your job is to assign you are given a network address, sorry. Now your job is to assign IP addresses to all the devices. You look at the requirements that you have, ndochagadzira ma subnets, different subnets to assign to different networks. You all understand why we have subnets, why subnet a network. There are reasons why we subnet a network. I think you can always refer to the first video I think I sent on IP addressing. Right, you know why you need to subnet. Now going into the subnetting, or you look at the number of hosts that you have. I think the first step I summarized the subnetting, vlsm subnetting scheme into different steps. In the first step, kuronga ma networks akho with decreasing number of hosts. So network in hosts akawandisisa becomes the first network that you'll be subnetting, you'll be assigning a subnet. So which means here we'll be assigning this first, this is the second, third, fourth, and lastly, this one link. So we start with the 58 hosts. We're going to start with the 58 hosts. That is switch 4 LAN. So we're going to start with switch 4 LAN in a 58 hosts. Ndio yatanga kuassign a subnet. Ndio yatanga kuassign a subnet. So our network, originally we had 192.168.720.0/24. This is the network address from the ISP. Right. Easier subnetting. There is a table that I gave that makes for easier subnetting. In the table, it had, let me create another page for this one. It had number of subnets, I think I'm gonna make a straight line there. This one. So number of subnets. We also have number of hosts. Then we have the subnet mask. Very easy to come up with this table. This is the subnet mask as well. All right. Lastly, another line here. Okay. So here we have number of hosts. per each subnet. We have the mask. We have another mask here, the complete one. Right. So it goes like this. You just go from one number of subnets. This is 2 to the power of n, by the way. Number of subnets, where n is the number of bits. If you go back to IP addressing the rectangle, in bits, 4, 8, 32 bits. So for every 1 bit, you have 2 to the power of n subnets. So here we have 2 to the power of n, that is 0, to the power of 0 when n is 0. 2 to the power of 1, this is 2, 4, 8, to the power of 3, to the power of 4, 5, 6, 128, then lastly 256. On the number of hosts, it's the other way around. You start with 1, we go to 2, then we have 4, 8, 16, 32, 64, 128, 256. The subnet mask /24, /25, /26, /27, /28, 29, 30, 31, /32. The complete mask, it will be here 255.255.255. This starts with 0. This goes on to 255.255.255. This becomes 128.128. This .192.255 remains. 224, 240, 248, 252, 254. You see, this subnet, it can be used. There is no subnet in any one host. It's impossible to use that subnet. Even this one, it will be impossible to use this subnet as well. Because for the number of hosts, it's always the number of hosts, this number given -2. -2, where we have one address for the network address and the other for the broadcast. So it will be difficult, if not impossible, if not, it's impossible to use these last 2 subnets to address, right? So we'll be using the rest, the room thorough, right? So for the first, this is how you're going to be using the table. If you have this table, by the way, very easy to do subnetting, very easy. Even if you don't understand the bits, the ones and the zeros, you can start with that table, right? So for this network, speed 4 line, 58 hosts. How do you create a subnet for that network? So unaenda pa table, unotsvaga corresponding pama number of hosts panapa. My requirements is 58 hosts. So as we can see, this one ndio inokwanisa kuaccommodate my number of hosts edu 58. 32 is too short. 128 akawanisa static. 64 can accommodate zvakanakisa static. So you take 464.26. Oh yeah, now this is the subnet we are going to be using. 464.26/26. What this means, you're going to create 4 subnets. Sorry. You're going to create 4 subnets. Each subnet with 64 hosts. That is 62 addresses at no said assignable addresses. 64 minus 2, 62 assignable addresses. And your subnet mask will be /26. Basically, that is what 464.26 that is what it means. Right. So from there, wakutotanga kuno isa ma subnet ako. The first subnet chinenge chakuchinja apa, provided this network chakuchinja apa is the subnet mask here. The /24 is going to change. And the first address you're going to assign is address your on ISP with a different mask, 72.0/26. Chatangochinja is the mask for the first address area subnet. Then the next address, so this becomes our first subnet. For the next address, you add this number here, 64, the total number of hosts, including the network ID and the broadcast ID. So if you add 64 here, you get 192.168.72.64/26. Then you have your second subnet. This becomes our second subnet. For our third, you add another 64 here. So you have our third subnet 168.72.64 plus 64. That's 128/26. And our for our fourth subnet 192.168.72.128 plus 64. 192. Yes, 192/26. Right. So for the first network in a 58 hosts, we have created 4 subnets. Each of the subnets inokwanisa fulfill my requirements edu. And so we're going to choose one from those 4. We're going to choose one. So we're going to choose this one. And that becomes our first subnet. This one in red. That becomes our first network, this one. 192.168.72.0/26. The rest of the networks in the sides, we are going to be using them to assign my networks. Okay, we're going to be using this to assign to the other networks. So meanwhile, Papa, let's take this address. I'm going to create another table. We need a table like this one, so that is it's easier. Blue. All right, we need a table for like this one, where we have the network. Let's start here. So this is the network. We have the network ID. An ID, the network ID. We have the first address in that network. We have the last address. Then we have the broadcast ID. So why we have this is so that we simplify. Addressing yedu, it makes it easier because first address network yedu in the IP. Second address network yedu in the IP. Last address network yedu in the IP. If we want to broadcast, which ID are we going to be using? It makes it easier to do all those things if you have a table like this one. But can always use or you don't need this table. You can go directly assign my IP addresses. But in this case, we're going to be needing this table learning purposes. All right, so for our first network, you see with the 192.168.72 part, it will not change. .x. Change in the x everywhere per my networks edo. So we are going to be using this .x to show my networks here now. So the first network atatanga kwa assign it's switch 4 line, I think. Let me check. Right, it's the switch 4 line link. So the network is .0/24. The network ID is 192.168.72.0/26. That's the first network atatanga kwa assign there. Right, and the first address you see, it will be .1. That will be our first address. Pano. Tiripana. First address E1. Second 2, 3, 4, 5, 10, 20, 30, 40 until you're going to approach another network in 64. So the broadcast ID is much easier to do this. The broadcast ID is 64 minus 1, 63. The broadcast ID, I think, is much easier to assign for this network. 63, automatically the last address, it becomes .62. Broadcast ID. That's how you identify my network side. So if we were to choose this second network here is to be our network, it will mean our first address will be .65. Our last address, we look at the broadcast first, 128, 127, that's the broadcast, which means our last address will be .126. Everywhere you look at the next network, you look at the broadcast ID, you look at the last address, you look at the first address. So for the first network, we have network ID complete up. Switch for LAN, first network address 192.168.72.1. This last address .62, the broadcast address .63. Switch for LAN yedu done. So kanataka assign my addresses in that network. You see there is a habit to the first address assign by interface per router, which becomes the default gateway. Then from there, my addresses is wangotora or kuda my PCs unotora between 2, 3, 4, 5 kusvika 62. Right. Toenda to the next network. Next network yedu pana let's another page. The next network let me go back here. So the next network we are going to be dealing with in the switch 3 line in a 29 hosts. All right, 29 hosts. Let me put it here. All right. Okay. I do this. Then we have our switch 3 line with 29 hosts. All right. Which subnet are we going to assign our switch 3 line in? Tinodzoka panapa. Here we look at one yatorwa. Excuse me, one yatorwa need the first line rata creator, subnet rata creator. Then the rest 3 asara, we are going to be using it to address among my networks at negative now. So we are going to take this address first to start 192. So we're going to take 192.168.72.64/26. That's the subnet. We are going to be subnetting again to assign kunimango ma networks. Right. Todzoka pa table yedu. From there, todzoka pa table yedu, we have 29 hosts. To address 29 hosts, what do we need? We need this combination here. 32 addresses. So 29 fits very well, Papa. So 8, 32, 27. Magic number at Cheshire is 8, 32, 27. From there, the first subnet, what this means, let's start with what this means. It means you're going to create 8 subnets here, each with 32 hosts, 30 addressable, 32 minus 2, and your subnet mask will be /27. Okay, all right. So, 8 my subnets edu, the first subnet that create is 192.168.72. It takes the network ish. What changes is the subnet mask. This becomes the first network. First subnet, if I can put it like that, this becomes the first subnet, this one. The second subnet, you add this number, 32. So plus 32 here, we get 696.96/27. This becomes the second network. The third network, you add 32, 8 becomes 128/27. The fourth network, you add 32, and you continue like that. You continue. If we add 32 here, let's see, 0, 10, 6, 1. So this becomes another subnet. This one, 160/27. I think you get the idea. So you create 8 subnets here. From those 8, you choose one. You want to assign her to the 29 hosts. So we're going to choose this first one. Then assign her to the 29 hosts. Mango 8 SSRI, Mango 7 SRI. We're going to assign to other networks. That's how variable length subnet mask scheme works. So these, the rest is, those are chatton address in the future to other networks. You see with this, tukusarati now, these two as well asata shanda, tukusarati now as well. All right? That's how we don't waste my IP addresses using vlsm. Right. So we have assigned the second network. This one becomes our second network. Total filler table area is .64/27. To open up. Switch 3. So it's .64/27. Right. Our first address becomes .65 from here. Our broadcast address, we look at this one, 96. So 95 becomes our broadcast address. So we have .95 here. Automatically here we have .94 being the last address in that network. And we continue. All right, to end up an M1 network. So I'm going to remove this one. All right, because network down there. Let's remove this one. To end up an M1 network. All right, like this. All right, okay. So for the next network, that is switch 2. This one Tadilanayo. This one we've dealt with this one. 2 Tadilanayo. 3 Tagarapa 3 in 15 hosts here. That is switch 2 LAN with 15 hosts. Right. Twenda pa table yedu, magic number yedu 15 hosts. 16 aito because this one can address maximum 14 addresses. So we're going to be using this same magic number 832/27. Same magic number 832/27. Now I the same magic number, it becomes very easier to pick address yako. Obviously, you are going to pick the next one. Panama/27, bana. Running out of time. Okay. You're going to pick this one in /27 easily. You're not going to subnet a subnet because my requirements are with the fit address here. So we just pick this one in a .96 as our network. So for this subnet, it's 192.72.64/27.96. I mean, .96/27. This becomes our address. Right. So going back, uh, since 2 cents for now, I think our time is running out. We're going to restart this to tangle pop up switch line 2. So we're on switch line 2, type address with that. Okay. That's why you're paying me $80, man. So that I can subscribe to Zoomer Unlimited. Okay, I'm going to end this session. Come on, dear. Okay, done for this one.